Good morning, guys. Sorry, good evening. Hope you had a good day today. So we'll talk about solving trig functions the first day. On the first day, let's see, Genesis 1:1. On the first day, the earth was formless and was, oh man. Anyways, this is day one of solving trig functions. If you, like me, don't remember Genesis 1:1, then we need to do some self-checking. So we've looked at so many formulas, so many ways to express trig functions in different ways, different perspectives. So we just try to put all of that together and try to use it to solve equations. And again, I want to answer the question, how is this going to help me in my life? Honestly, the biggest gain that you get from this unit, or these equations of trig functions, the identities, is learning how to manipulate information quickly, differently, and use it to solve a problem. That's a very valuable skill, and on the largest part, that's what most people benefit from mathematics. Knowingly or unknowingly, these mathematics principles are what help your brain, or is the exercise that your brain needs to build the strength and endurance and perseverance to solve problems, or to look at a problem and not fear it and see that there's going to be an outcome, there's going to be a solution. Obviously, some of you will use it once you do higher courses that involve math, physics, chemistry, but on the most part, it's your brain that's benefiting from the exercise. So you can thank these trig equations for how impressive your brain is getting at solving problems on the go. Anyways, enough talk. How many solutions are there to the equation sine x is equal to half? Well, it's asking me how many angles can I plug in here and get a result of a half. Well, if the domain is not defined, then this is infinite, because I know the sine of 30 degrees is a half, and I know in the second quadrant I have 150 degrees, its sine is a half. When I go around again after 360, I'll have in the first quadrant 390 degrees, and if I go around, this is what I'm talking about. This is your 4 quadrants, right? In the first quadrant you have 30 degrees, in the second quadrant you have 150 degrees, that is 150 degrees. So every time you go around, if I go around the first time and I've gone to 180 degrees and I keep going, I'll come back to this angle, which will be 360 plus 30, which will be 390. And then I'll keep going and I'll get to this quadrant again, and I'll find whatever angle that is. I think that's 720, no, something, right? And if you keep going, you come back again to this angle, and then you go again to that angle. So if the domain is not defined, then there's infinite angles that satisfy this equation. There's infinite solutions to this equation. However, if the domain is defined, if you were told that the domain, if you're told that how many solutions are there to this equation there for the domain 0 to 360 or 0 to 2 pi, then if that is defined, then the only thing you have is 2 angles, because if you draw the line y is equal to a half and you figure out where that line cuts the graph, so those angles will be this angle and this angle only if the domain is defined as 0 to 2 pi, right? So it will just be this angle, which will be 30, which is pi over 6, and this angle, which is 150, which is I don't remember, but yeah, it's 150. In radians, I do not remember. Yeah, if the domain is defined, it's just 2 angles. If the domain was negative 2 pi to 2 pi, then you have 2 other angles here. Where x is a half, you have 2 other angles, that one and that one. However, if the domain is not defined, then as you can see, it can be so many infinite angles. Just a recap, the period of a sine function is 2 pi, the period of a cosine function is 2 pi, and the period of a tan function is pi. The reason why we are recapping this is a lot of the times when you're asked to solve for values of sine or cosine or tangent, they're going to be asking for solutions that are within one period, right? So on this question, we needed to specify, on the previous question, we needed to specify that the domain was 2 pi. That's because the period of one sine function is 2 pi. So a lot of the times, the questions are going to be specifying that you solve for x of theta in the domain of 0 to 2 pi because that's the period. That's one period for each of these functions. For example, is x is equal to pi out of 11 pi out of 6, is that a solution to sine of x equals a half? Again, the domain is 0 to 2 pi. Ask yourself, what is 11 pi out of 6? 11 pi out of 6 is, I think, 330 degrees. Yeah, because I'm just multiplying. I know pi out of 6 is 30, so I'm just doing 11 times 30, which is 330 degrees. So 330 degrees is in the fourth quadrant, and in that fourth quadrant, sine, despite having a ratio of half, which is the same magnitude as this half, despite having a ratio of a half, in that quadrant sine is negative. So x is equal to 11 pi out of 6 is not going to be a solution to the function. It's not going to be a solution to this function sine x is equal to a half, because this question is asking you, what angle do I plug in here to get a positive a half? And 11 pi over 6 is not one of those angles, because if you see, the sine value for 11 pi over 6 is negative a half, and that is not one of, that's not a solution. So the answer to this is no, it's not a solution to sine of x is equal to a half. Right, let's move on. Solve the equation 2 cosine theta plus square root 3 is equal to 0. You're going to see these equations a lot that have interesting terms. Your first approach, please do not be scared. These are just things that have been solved so many times by so many people, so it's possible because you are another person who can solve this very ably. So just go back to the basics and start with what you know. If this is an equation and I'm trying to solve for theta, because the only unknown here is theta, that's the only unknown, then I need to isolate it. In order to isolate it, I'm going to subtract 3 from both sides. Subtract root 3 from both sides. Subtract root 3 from both sides. So when I subtract root 3 from both sides, I'll be left with 2 cosine theta is equal to negative root 3. So again, I want to isolate theta. To isolate theta, I'm going to divide by 2 both sides. So divide by 2 and divide by 2 that side as well. The 2's cancel out on the left hand side, and then I'll be left with cosine theta is equal to negative root 3 divided by 2. So at this stage, I can, if I'm not allowed to use a calculator, I can ask myself, what angles give me a cosine of negative root 3 over 2? Now I know that cosine root 3 over 2, one of the angles that gives me a positive cosine of square root 3 over 2 is 30 degrees. Because in that triangle, if this is 30 degrees, this is going to be root 3. The adjacent is root 3, the opposite is 1, and the hypotenuse is 2. From that triangle, I can see that the cosine of 30 is square root 3 divided by 2. So since square root 3 over 2 is the cosine of 30, I'll just be trying to look for an angle that gives me the negative of that. So I'll look for that in the quadrants. So I'll go to the quadrants. I don't expect that to be in the first quadrant because that's positive 30. I expect it to be in quadrants where cosine is negative. So in this quadrant and in this quadrant. And if it's in those two quadrants, then this acute angle here has to be 30 degrees. Oh, sorry, not that quadrant. Thanks for reminding me, Hudson. That's a good eye. It's going to be in the second quadrant where this angle is 30, and in the third quadrant where that angle is also 30. So according to this angle will be 150 degrees, and this angle will be 210 degrees. So the solution to this equation over this domain from 0 to 2 pi or 0 to 360, the solution is the two angles 150 degrees and 210 degrees. And I just need to change that to radians. 150 degrees, change that to radians, and 210 degrees, change that to radians. So just to show you on this graph, if this is my graph, then and I try to draw the line y is equal to negative root 3 over 2. This is calling back on your 9th grade knowledge. If I'm trying to solve this equation, which I simplified up to this stage in the previous screen, and I try to draw y is equal to negative root 3 over 2 on the same graph, then that line where that line cuts the graph are going to be my solutions. So I look for parts where that line cuts the graph within my domain. This being my domain, the only 2 points it cuts the graph are there and there. And those are going to be 210 degrees and 150 degrees and 210 degrees. So yeah, the only thing you need to do is change it to radians. 150 pi over 180, which is by 3, 5 pi over 6, and 210 pi over 180 by 3 is 7 pi over 6. Yeah. All right. Next question. Solve this equation. Cosecant squared x minus 4 is equal to 0. Again, you need to solve for x. So however complicated it looks, it is possible. You just need to isolate your x. If I want to isolate this x, I'll start by adding 4 to both sides. So I'll end up with cosecant squared x is equal to positive 4. If I want to get still isolate the x, I will take square root on both sides. So taking square root on both sides, I take square root of cosecant squared, and I take square root of 4. So I'll be left with cosecant x is equal to, when I take square root, I get a positive or negative 2. Now I know that cosecant is the same thing as 1 over sine of x is equal to plus or minus 2, which is the same as 2 over 1. So since it's the same as 2 over 1, I can do reciprocal on both sides, and I won't have changed the meaning of this equation. What I mean is, I can do reciprocal on the left-hand side, and it will just be sine of x. And if I do reciprocal on the right-hand side, it will be plus or minus 1 over 2. This is a quick way to get from here to here, but obviously you can go through the more comfortable process of cross multiplying and then still isolating sine x, but I promise you you'll get to the same thing. So now I have sine of x is equal to positive half, or sine of x is equal to negative half. Since this domain restricts me to positive values of the angle only, the negative half I can discard because that cannot give me positive angles that are in this domain. So I'm going to be working with sine of x is equal to positive half only. And then the only thing that I have left to do is figure out what angles between 0 and 360 give me a sine of a half. Well, that's an easy one, because you remember that the sine of 30 is a half. So the angle in the first quadrant is going to be 30. And the angle in the second quadrant is going to be 180 minus 30, which is 150 degrees. This is 150 degrees, and this is 30 degrees. So my two solutions for the angle, I can write my expression as x my final answer as x is the set of angles that includes 30 degrees and 150 degrees. But be careful, your question was asked in radians, so you need to state your answers in radians as well. Radians 30 is pi over 6, and at this stage, a bunch of you guys know what 150 is. So how many 30s are in 150? Those are 5 30s, so I'll be 5 pi over 6. Because pi over 6 is 30, so there's 5 of those in 150. Okay, next one. Solve the equation 2 cosine theta is equal to -1 for this domain, 0 to 2 pi. Again, isolate the unknown, isolate the variable. If I want to isolate this variable, step 1 is I divide by 2, such that I only have the cosine function left on the left-hand side. Now, after dividing by 2 both sides, I'll have cosine of 2 theta is equal to -half. Now, the only way I can isolate this 2 theta, right, because 2 theta is the angle, is all of it is part of the angle, is if I figure out what values of this angle, think of this as just one angle, what values of this angle can give me a half. So what values of whatever is in front of a cosine can give me a value of a half. Another way to think of this is if I want to isolate 2 theta, then it's going to end up being 2 theta is equal to the inverse cosine of -1/2. And I hope you remember that that's the only way I can detach the cosine function from the angle 2 theta. That's how I can detach it from the angle 2 theta. So now I'm asking myself, which angles give me a cosine of -1/2 between 0 to 2 pi? Those angles are, I know the acute angle for that is 60 degrees, and I know that cosine is negative in that quadrant and also in this quadrant. So this is going to be 60 degrees, which means that angle is 120 degrees. This is going to be 60 degrees, that means that angle is 240 degrees. So 120 degrees is 2 60s, and I know that 60 is pi over 3 in radians. That's going to be 2 pi over 3. And 240 is 4 60s. And since I know that 60 is pi over 3, that's going to be 4 pi over 3. Both of those angles are equal to 2 theta, but I am interested in theta alone. Since I'm interested in theta alone, I'm going to divide my answer by 2. So I'll divide each angle by 2, by 2, by 2. That ends up giving me theta alone being equal to 2 pi over 2 over 3 divided by 2 is the same thing as 2 pi over 6. And 4 pi over 3 divided by 2 is the same thing as 4 pi, again, over 6. These two can reduce to pi over 3. Wait, am I right? And 2 pi over 3. Yeah. You can plug these into a calculator just to check yourself to see if both of these angles put here give you a value of -1 if you multiply the function by 2. Also, if it is confusing to work in radians, feel free, which is not advisable, and Miss Williams doesn't like this, but I still feel free to work with degrees here, because if you're working with degrees here, you'll have this as 120. Let me do it in a different color. If you're working in degrees, you'll have this as 120 degrees and 240 degrees. And then when you divide it by 2, then you'll have this as 60 degrees and 120 degrees, which 60 degrees you can convert back to radians and 120 convert back to radians. You just need to be careful not to forget to convert your final answer to radians. Yeah. Eventually you'll get used to working in radians and you'll just be like a radian clock. But yeah, it takes practice to get there. Use your calculator to solve sine of theta equals 0.4. So I told you earlier that the only way to detach the angle from the function is to take the inverse function. So if I want to detach this function from the angle, is theta is going to become the inverse sine of 0.4. What I basically did is I introduced the inverse function on both sides. I introduced the inverse function on both sides. That's what I did. That's what I basically did. And you remember that the inverse function of sine, it's the same thing, so that will just be theta. And then that's how I have theta is the inverse sine of 0.4. And you can go to your calculator and just find the inverse sine of 0.4. So 0.4 inverse is 23.5. And then I'll go back to this and say that my angle is equal to 23.5 degrees. Use your calculator to solve again. Since cosine theta is negative 0.9, then theta alone will be the inverse cosine, of negative 0.9, inverse cosine of negative 0.9. So go to your calculator and then plug in inverse cosine of negative 0.9. 0.9 negative inverse cosine 154.15. I hope that makes sense, because if you're finding the angle on between on the domain 0 to 2 pi, then the one that gives you a negative cosine is going to be in that quadrant and that quadrant. Now, these two questions did not specify whether your calculator should be in degrees or radians. So, yeah, you can either way we were able to get an answer in these cases. But if the question specifies, then don't forget to put your calculator to degrees or to radians. All right. Hope that was helpful. We'll do some more practice questions on this tomorrow. This is your homework for now. Bye.